Quick review. How do you find the area of a parallelogram when the parallelogram is defined, two sides of the parallelogram are defined by vectors in 2 or 3 or actually n-dimensional space? I'm going to flatten this down into 2-dimensional space because it's easier to visualize, but it holds for higher dimensions as well. What's the area of a parallelogram? It's just base times height. It's going to be the exact same area as if this had been a rectangle. It's like a rectangle that's been shifted to the side, sort of like if you take a deck of cards and squish it over to the side a little bit. It's going to have the same area whether it's squished to the side or not, as long as you're taking it from the height given here and not the length of the side. So let's compute that. What is this height here? Well, we'll have to use triangle geometry, right? If I'm thinking of this as an angle theta, then the height is going to be the sine of theta times the magnitude of my length w, right? Because for that triangle, I'll redraw this triangle. This is my hypotenuse, which is the magnitude or length of my w vector. And this side length is the opposite side, and so I know that the sine of theta is going to be equal to opposite over hypotenuse, which in this case is the opposite side that we're trying to find over the magnitude of w. Thus, the magnitude of w times the sine of theta is going to be equal to this opposite side, which was the side length that we were trying to find. Height, h is a bad letter to use. Maybe I'll use a lowercase h to represent the height there. So that's the height. What is the length of the base? So the total area is going to be length times height, and the length in this case is just the magnitude of b. So this is the magnitude of b, which is the length of the base, times the total height, which is the magnitude of w, times the sine of the angle between them. But wait! As you recall from some of the properties that we discussed of the geometry of cross products, this is exactly equal to the magnitude of the cross product of b crossed with w. Thus, if we want to find the area of a parallelogram in 3 or multi-dimensional space, it's always going to be equal to, maybe I should say area is equal to the magnitude of the cross product of the vectors that compose the sides.